In this video, you will learn about Python decorators. We will explore how they can modify function behavior in an elegant way. Decorators are a powerful feature in Python that allow you to enhance and extend the functionality of functions and methods. Let's dive in and understand how they work. Decorators are a powerful feature in Python that allows you to modify the behavior of functions or methods. They follow the wrapper design pattern and use the symbol, that is, the commercial symbol, as syntax sugar. On the right, you can see a simple decorator example. We define a function called my_decorator, which takes another function func as an argument. Inside my_decorator, we define another function called wrapper. This wrapper function adds some behavior before and after calling the original function func. The my_decorator function returns the wrapper function. We use the symbol my_decorator syntax above the say_hello function to apply the decorator. Let's understand how decorators work step by step. First, you create a wrapper. A decorator is a function that takes another function as an argument and returns a new function that usually extends the behavior of the original function. Second, you apply the decorator. Use the symbol decorator name syntax above the function definition to apply the decorator to that function. And third, function replacement. The original function is replaced with the new function returned by the decorator, preserving the original function's name. Here's a basic decorator example to illustrate how it works. First, we define a function called timing_decorator, which takes another function, func, as an argument. Inside timing_decorator, we define a wrapper function. This wrapper function prints a message before and after calling the original function func. The timing_decorator function returns the wrapper function. Then we use the symbol timing_decorator syntax above the my_function definition to apply the decorator to that function. When we call my_function, it will execute the wrapper function, printing the messages in the main function execution message. Here is the output: starting timing, main function executed, and finish timing. Now let's explore decorators with arguments. Here's an example where the function being decorated has arguments. We define a decorator function called debug, which takes a function func as an argument. Inside debug, we define a wrapper function that accepts any number of positional and keyword arguments using *args and *quargs. The wrapper function prints the function's name and arguments before and after calling the original function. The debug function returns the wrapper function. We use the symbol debug syntax above the add function to apply the decorator. When we call add with arguments such as 5 and 3, it will print the function's name and arguments and return the result. Decorators can also accept their own parameters using nested functions. Here's an example. We define a function called repeat, which takes a parameter n with a default value of 1. Inside repeat, we define another function called decorator, which takes a function func as an argument. Inside decorator, we define a wrapper function that calls the original function func n times and returns the result. The repeat function returns the decorator function. We use the symbol repeat with n=3 syntax above the greet function to apply the decorator. When we call greet with a name, it will print the greeting 3 times. Let's explore some real-world decorator examples. First, timing function execution. In this example, we define a decorator called timing that measures the execution time of a function. It prints the time taken to execute the function. We use the time module to measure the start and end times. Second, authentication check. Here we define a decorator called require_auth that checks if a user is authenticated before allowing access to a function. If the user is not authenticated, it returns an access denied message. Otherwise, it calls the original function. You can chain multiple decorators to apply multiple modifications to a function. Here's how it works. We define 2 decorators, bold and italic. The bold decorator wraps the function's output in bold tags, and the italic decorator wraps the function's output in italic tags. We apply both decorators to the greet function using the @ symbol syntax. Decorators are applied from bottom to top. In the example, the function is first wrapped by italic and then by bold. The result is bold italic hello world. Decorators can also be implemented as classes by defining the call method. Here's an example. We define a class called countCalls. In the init method, we initialize the function func and a counter count to 0. In the call method, we increment the counter, print the call count, and call the original function func. We use the @ symbol countCalls syntax above the say_hello function to apply the decorator. When we call say_hello, it will increment the counter and print the call count before returning the greeting. Here are some best practices to follow when using decorators. First, use functools.wraps. Always use @functools.wraps with func in your wrapper function to preserve the original function's metadata such as name, docstring, etc. Second, return value. Make sure your decorator returns the decorated function's return value, unless you explicitly want to modify it. Third, documentation. Document how your decorator modifies the function behavior. Consider adding examples to your decorator's docstring. And fourth, single responsibility. Each decorator should have a single clear purpose. Create multiple decorators instead of one complex decorator that does too much. Use decorators to create clean, maintainable, and reusable code. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.